Hello everyone, let's solve this LeetCode problem number 1091, shortest path in binary matrix. Let's see the description for this problem. So, given an n by n binary matrix grid, so return the shortest of the path, of the shortest clear path in the matrix. If there's no clear path, we return -1. So what's the definition of a clear path? So clear path is a binary matrix. A clear path in binary matrix is a path from the top left cell, like this 0, 0, to the bottom right cell. Okay, so here. So the clear path actually is all the visited cells of the path are 0, right? So are 0. Let's see this example. If we do this way, right? So it's all are zeros. If here is 1, or here is 1, or here is 1, so it's not a clear path. Okay, so all the adjacent cells of the path are directionally connected. That means that if we check the adjacent cells of the path, we check a direction, we check it down, up, like right, left, and also this corner, 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 corner. So it's a direction. Okay, this is a definition of the clear path. So for this problem, we are going to return the length of the shortest clear path in the matrix. In this example, so we can go from the from this top left to the bottom right. We have two ways. So we can go this way, this way. We can go this way, right? So we have two ways, but we are looking for the shortest one. So apparently we can see from here to here is shortest than this one, right? So this is 1 step, 2 step, 3 step, 4 step. So in this case, we are going to return 4. Okay, step 4. This is basically the problem we are trying to solve. Okay, how do we solve this problem? We make this one. This one is a grade. Is equals to that one, right? So what we do first? So first, we will actually use the Q. We will use the Q data structure. Q is first in, first out. Okay, so we will use the BFS algorithm. So to implement the BFS algorithm, we use Q, and also we will use another array, another Boolean 2D grid. It's called visited. Okay, so the grade equals to this one. So we are actually this input. So we are actually need another 2D grade is visited. Okay, so initially our visited 2D grade is like this. So first, what we do, we just offer the first one, the 0, 0 to our queue. Okay, so we offer this one to our queue. So 1 second. Okay, so we will offer this one 0, 0 to our queue. Okay, the step initialize, the step here is 0. This initialize is 0. Okay, so first what we do, we will check the queue size. Okay, so in this way, the queue size right now is 1. Okay, is 1. So we will do a for loop. We will loop every single cells in this current level, and then first we will pull this cell out, and then we will check if this cell is the bottom right cell. Okay, and then we check this one is not bottom right cell, and then we will do the A direction. Oh, let's use this example. We will do A direction BFS for this cell. So A direction, let's do down, up. Okay, so we start from down. So when we check the down direction, so the down direction, this one is not visited. It's not the corner. It's not out of boundary. But this one. But this cell equals to 1. That means this is a wall, right? This wall, so it's invisible. So it cannot be the clear path. Okay, so for this problem, we just return when we visit this direction, and then we will visit the up directions, but up direction is already out of boundary, right? So we just return, and then we will visit this direction. But when we visit this direction, let's see, so this one is not out of boundary, also is never visited, and also it's not equals to 1. If equals to 1, that means that's a wall. So in this case, what we do, we just offer this cell to our queue and make it visited. Okay. Oh, first, we have to make this one as a visited. But now we are visiting this one. We mark it visited. We put this one is 0, 1 to our queue. Okay. It's gonna be 0, 1 to our queue. Okay. After we put this one, we will return. We will return check another direction. Okay. And then we check this direction, this out of boundary, and then we will check this direction. This one equals to 1. It's not equals to 0. It's not a clear path. Okay. So we will return, and then we will check this direction is out of boundary and boundary, so we will return. And then we will check this direction is out of boundary, we will return. We check this direction is out of boundary, we will return. So we iterate every single direction for this cell. After we finish all this one, so what we do, we will check another element because the size is just 1. So that means in this current level, we visited all the cells already. So what we do, and then what we do, so we do step plus. So we do step plus, but now, yeah, the step right now is 1. Okay, is 1. Okay, because we just checked, right? So and then we will check the queue after we finish this. So we will check the queue is empty or not. So in this case, it's not empty. We still have this one. So we still have a 0, 1. So what we do, we just check the size of the queue. In this case, the size of the queue is 1, and then we will pull this out. And then we will check this the current cell is the bottom right corner. Is this cell? No, it's not. It's not. That means we still have to do more steps. And then we will start from here, do the A direction check. Okay, so when we do the A direction check, first we check this one, the down direction. The down direction is equals to 1, so we just continue. We check up direction is out of boundary, we continue. And then we check the right direction. The right direction is not out of boundary, it's not visited, and it's not equals to 1. So what we do, we offer this one to our queue and then make it visited. So we offer this one to our queue. This one is 0 and 2. And also we will update this one as visited. Okay, after we do this, and then we do one more direction. So we are checking this, we checked this, we are checking this direction, and then we will check the left direction. Left direction is already visited. So we will check this direction. This direction is not out of boundary, it's never visited, it's not equal to 1. So what we do here, we offer this one to our queue and make it visited. So this one is gonna be 1 to the. Okay, we will offer 1, 2 to this one. We will offer 1, 2 to our queue and make it visited. Okay, and then after we do this, what we do then? And then we will check another direction, this direction. This direction is out of boundary, we don't have to do it. And then we check this boundary, we check this cell, this direction. This direction is equals to 1. So it's blocked. It's kind of a wall, right? And then we check this direction out of boundary. So we just return. So we just go back to here. And then what we do, we finish the check all the direction for this one. And then after we finish check all the direction, what we do step plus. That means we have the step 2 here. Okay, in this current level, right? This is one step here. This is another step here. Okay, and then we will check the Q is equals to is greater than 0. The size of the Q greater than 0. Yes, it's 2, right? It's greater than 0. So we get the size of the Q is 2. After we get the size of Q is 2. So what we do, we iterate every single cell in the current step. Okay, so we pull this out. Is 0, 1. We pull this out, and then we will check if this one is the bottom right cell. No, it's not. So we will and then we will check the 8 directions for this cell. So the down direction is 0. But it's visited, right? So we just visited here. So it's already visited. So what we do, it's already visited. We just check another direction. We check this direction, and it's already visited. And this direction is out of boundary. So this direction is equals to 1, is blocked, is a wall, right? And then this direction is out of boundary, and this direction is already visited. And this direction is equals to 1, is a wall. So this direction is out of boundary. So we checked all the direction for this cell. And then what we do, we will pull another one out. Okay, we will pull this one out. 0, 1, 2. Okay. Sorry about that. Let's check. Is 0. Okay. Sorry about that. Actually, we pull this one out. Let's explain again. So we pull this one out. We are checking this direction, right? So we are checking down is visited, up out of boundary, visited, blocked, out of boundary, So we checked all this one, right? And then we will check this one. So when we check 1, 2. This 1, 2 here. So when we check 1, 2, so what we do, we will check the down direction. The down direction is 0. That means that we never visited, right? We never visited, and is 0, is not out of boundary. So what we do, we offer this one. 1 second, that's another layer. So that's another step. So we offer this cell to here. We offer it, and then we will make this one as true. No, as visited. Okay, visited is equals to true, and then we check this direction. We check up direction is 0, is visited, and this out of boundary, this 1. And this one out of boundary, this direction is visited. This direction is a wall. This direction is a boundary. So we checked all the direction for this cell. After we check this one, so definitely we already iterate every single cell in this current level. So and then we step plus. So step plus. We got a 3 step. And then we will check if the Q is empty or no. So here is not empty. So what we do here, we just check the size. We get the size of this step is 1. Okay, this level is 1. So we pull this out. After we pull this out, we will check we pulled this out. We will check if this one is a bottom right cell. Yes, it is. So in this way, we just step plus plus, step plus one, and then we return. We just return 4 now. So we just return. Okay, so basically that's the algorithm for this problem. So let's start coding. So when we start coding first, what we do, we will actually declare the A direction connected matrix. A direction matrix is gonna looks like this. We call it a data, and then new int this one. So we have 8 direction, right? So this is a 1. Oh no. 1 second. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 direction. So the direction actually you can define any, like you can. So for me, I start from down direction and upper direction, but you can change direction. You don't have to use this exactly order, but you can use another order. So for me, I'm checking down direction, up direction, and the right direction, and then left direction. After the left direction, I do another kind of the down corner direction, 1, and then I do -1, -1, -1, -1, and then what we do here, after we do -1, -1, what we do, we still have a 1 second, we do -1 and the 1. Also we have 1, -1. Okay, this is our A direction matrix. Okay, this is our A direction matrix. We have to kind of declare here. Okay, so after we declare the A direction, first we will check the corner case. So what if this grid is empty? So if this one is equals to 0, if the row equals to 0, or the column equals to 0. So if a column equals to 0, and then what we do, we just return -1. Okay, after we return -1, what we do, we get the row, the number of row of the grade, and then we got the column of the grade. Okay, and then what we do here, we will do grade. Okay, so this one we will check if the upper left, I'm talking about here, if the top left, if this cell is equals to 1, or this cell is 1, then we just simply return -1, because that means we don't have a clear path. It is the start and endings is either of them. If it's 1, we don't have a clear path, right? So we checked here. So 0, 0. If this one equals to 1, or the grade, not this one, okay, the grade m-1 or n-1, if this one equals to 1. If this one equals to 1, what we do, we return -1. Okay, this is our corner case. And then we are doing a BFS, so we use a queue data structure. So we need to define the queue. it's an integer. No, it's a int array here. And then we name it q equals to new linked list. Okay, and then we need another Boolean matrix for our visited matrix. Okay, the name is visited. Okay, here's m. This part is in, and then what we do here? Just 1 second. So actually here is false. Okay, because this initially it is false. Okay. And then first, what we do, we are going to offer the top left corner, the top left cell to our queue. 0, 0. And then we will make the visited 0, 0 as true, because we start from the top left corner, and then we will initially we need this variable step equals to 0. This is initialize, and then we have a while loop, and we use a while loop. We will check the size of the queue is not empty. I mean, it's greater than 0. So if greater than 0, what we do? So we will get the size of the queue. That means we are getting how many cells in the current level or current step we can arrive. Okay, and then we will iterating all the cells in the current step. Okay, this one equals to 0, I smaller than size, and I plus plus. Oh, okay, this is what we're doing. And then what we do here, we will pull the current cell out from the queue. We just pull this one out. After we pull this out, the first step, we will check if the cur 0 is, let's check this one. So actually, this is a step we are checking if the one we just pulled from the queue, if the current cell is the bottom right cell, is a bottom right cell. Okay, so if it's a bottom right cell, we don't have to do any BFS. That means we already got it the pass, right? So our step +1, and then we return. That's basically the once we reach this one. Otherwise, if it's not the bottom right, and then what we do, we will continue start doing the BFS for the 8 direction. Okay, 8 direction equals to 0, d smaller than 8, and then d plus plus. So this is what we do. So this step actually we just pull the current cell out, and then we check the A direction. So if the this we calculate the direction. Okay, so if this part, if it's out of boundary, then we continue. Okay, so that means we don't have to check, right? So under this step is checking if it's visited or that cell is equal to 1, is a wall, then we continue, right? So there's no clear path. And otherwise, if it's not out of boundary or it's not visited and it's not a wall, so what we do, we will offer it to our queue and mark the visited as a true. Okay, this is the A direction. After we check the A direction, what we do, we will iterate the another element until we iterate all the cells in the current step. Okay, after we iterate all the cell in current step, what we do, we will check the another layer, another step. So we will check if the queue is size is greater than 0. If greater than 0, then we will continue to check until the queue is empty. After we check the is empty. So here we need to do step plus plus. Because after, see, we can start from here. We checked the current cell for the A direction, and then we check another cell, all the cells from there. After we check all the cells in current step, so that means we step plus plus. That means we got one more step, and then we step plus plus, and then we will check another. We will check if the queue have another step or not, and then if it's not if greater than 0, we will continually doing this until if there's no clear path. Okay, so we just simply return -1. Okay, if there's no clear path, we just simply return -1. Okay. Okay. Let's run the code. Line 2. This one expected. Oh, here probably 1 second. That's probably we do too much. Yeah, and then line 2, line 3. Let's run the code. Okay, it's accept. Okay. Okay, let's talk about the time complexity for this problem. The time complexity for this problem actually same as the binary tree level order traversal, the BFS. So for the time complexity for this problem is gonna be OMN, because we iterate every single cells in this matrix, and the size of the matrix is times n, right? So, and the space complexity is gonna be 1 second. It's gonna be the actually it's gonna be the. So the time complexity here, the space complexity here is gonna be mn. So the worst case is gonna be, if every single cell is 0, and then so we probably push everything to the queue. So the size is gonna be m times n. Okay, we just run the code, right? Let's run the code again. Okay, let's submit the answer. Let's check what's going on here. Okay, so our algorithm is faster than 76% of Java online submissions. Okay, it's not that bad. Okay, thank you for watching. I'll see you next time.